is tossed into the air travels in a curved path before hitting the ground?
This fascinating phenomenon is all thanks to projectile motion, a key concept in physics that highlights the amazing characteristic of an object propelled in air by gravity.
Projectile motion is defined as the motion of an object launched or projected into the air that is only affected by the gravity's acceleration. The object is referred to as projectile and its path is known as the trajectory. To gain a better understanding of this, we will go over its key attributes.
We have horizontal motion, vertical motion, parabola, acceleration due to gravity, angle of release, and initial velocity. These key attributes combined creates the physics behind projectile motion.
Before we proceed to the main demonstration, allow us to explain and showcase the three principles of projectile motion.
The first principle is the independence of horizontal and vertical motion. By launching one ball horizontally while holding the second ball vertically and dropping it. When the ball launches horizontally, it will travel on a curved trajectory as gravity pulls it downward. Both balls will touch the ground at the same time, demonstrating that vertical motion is independence of horizontal motion.
The second principle is Newton's first law of motion or inertia.
By placing a toy car on a flat table and pushing it forward until it rolls off the edge, the car keeps moving forward at a constant speed due to inertia, and gravity pulls the car downward, creating a curved path.
The last principle is the acceleration due to gravity.
By dropping two different things from the same height, they will hit the ground at the same time, proving that gravity has an equal effect on them.
Now, for the main demonstration, using this DIY ping-pong ball launcher and wooden catapult, we are going to analyze how the angle of release influences the ball's path and distance. By firing from different angles, we will observe how trajectory and precision play a role in hitting the target. 40 degrees launches the ball not too far. That's because it's directed more forward than upward, giving it less time in the air. At 65, the ball spends most of its energy moving upward more than forward. While it stays in the air longer, its horizontal range is reduced, thus making the 65 degrees the shortest distance. At 55 degrees, the angle strikes the perfect balance between upward and forward motion, thus making it the longest distance. Same as the wooden catapult, the lowest pull means maximum energy, which means that it will travel the farthest distance. The medium pull uses moderate energy, thus its distance would also be moderate. And last, low energy is used when slightly pulling, thus making their distance the shortest.
We have also created a parabola path diagram to visualize the trajectory of a projectile, showing the launch angle, maximum height, and landing point.
Now, back to our opening question. Why a ball that is tossed into the air travels in a curved path before hitting the ground? It is caused by the combination of horizontal and vertical motion. Together, these two form a curved path that is called a parabola.
Now that we've seen how projectile motion works in demonstration, let's break down the physics behind it. We'll look at the key attributes that affect the trajectory and how they work together to create this motion.
First, we have the horizontal motion. When the ball is tossed, it goes forward while in the air, which is known as its horizontal component of motion. Additionally, horizontal motion is constant. The ball keeps traveling forward at the same speed since there is no force pushing or pulling in that direction.
Second is the vertical motion. At the same time, the ball is moving vertically, moving up and then down. But unlike horizontal motion, gravity affects vertical motion. As the ball rises, gravity slows it down until it reaches the top of its path, at which point, the gravity pulls it back down, accelerating it downward.
Third, we have the parabola.
The unique curve shape we observe is the result of a parabolic route created by the combined horizontal and vertical motions. The ball goes steadily forward while gravity pulls it downward, creating the parabolic trajectory. As it moves through the atmosphere, this creates a smooth arc known as a parabola.
Fourth is the acceleration due to gravity.
The ball is pulled back toward the ground by gravity, which accelerates it downward at 9.8 meters per second squared. This constant downward force only impacts vertical motion, causing the ball to slow down as it ascends, come to a stop briefly at the peak, and then accelerate as it descends. The ball falls in a curve rather than a straight line due to gravity.
Fifth, we have the angle of release. The ball's height and range are influenced by the angle at which it is released. For example, the ball will move up and down with little horizontal motion if thrown straight up 90 degrees. When the ball launches at an angle, for example 45 degrees, it experiences significant vertical and horizontal motion, resulting in a longer curved path.
Lastly, we have the initial velocity. The initial speed of the ball when thrown impacts how far and high it travels. The ball will move higher and further before gravity pulls it back down, if its initial velocity is higher. The ball's width curves more when the throw is greater because it takes longer for gravity to bring it back down.
In summary, a parabolic path is created when the horizontal and vertical motions of a ball are combined under the force of gravity. The constant horizontal motion, the downward acceleration from the gravity, and the specifics of the throw such as the angle and the speed creates this curved trajectory. Together, these key attributes creates the ball curved, smooth trajectory before it strikes the ground.
Projectile motion is not only important in physics class, it has applications for everyday life as well.
Athletes apply these concepts to perfect their shots in sports like basketball and archery.
For safety and functionality, engineers must precisely calculate projectile motion while developing rockets and roller coasters.
These concepts are even used by fireworks to produce stunning displays and explode at precisely the right height and moment.
So, why is it important to understand projectile motion? By understanding these concepts, we can predict and control object motion, resulting in a safer, more effective designs in sports, engineering, and technology.
From a ping-pong ball to rockets in space, projectile motion truly is the science behind the perfect launch. Next time you see something flying in the air, think of the physics behind it.
Thank you for joining us today. Who knows, maybe next time we'll see each other again to discover the wonders of the world around us.